Is the printer sound too overwhelming? There's a printer running beside me.
No, sir.
So printer sound একটু শোনা যাচ্ছে
মানে এটা কি disturbing?
Fine, sir.
I actually need a lot of printing done tonight, so I prefer it on, or I could actually pause it. Should I pause it? I can pause it.
No, sir, it's fine. It's fine.
Acha, ঠিক আছে, fine. I appreciate everyone's cooperation. I would like primarily for you kids to start reading this, or I can. Do I have this thing somewhere? No, this is the only PDF that I have. I don't know what this.
Sir, আজকে আমরা P5 start করব?
This is just a lecture class for P5. I'm going to discuss in general what P5 is about. We are not going to be essentially doing something. This is let's say we're going to start P5 today's class. I'm starting P5 for the case that's as per the kids. Many of the schools, people who are going to the schools, the schools start at P5. So starting, we would have to start at any point, given that. That's a given. So it might as well be a good time to start right now. So not a big. So এই পার্টটা একটু পড়ো সবাই, এইটুকু পর্যন্ত পড়ো, and then we'll pick up new stuffs. এখানে একটু লেখা বাদ পড়ছে, with enough practice 15 of 15 in question number 1 is also possible, or you can also read is also almost never possible. You can read it either way. এটা কেন সেটা আমি তোমাদের বুঝাবো। এই প্যারাগ্রাফটা কি পড়ছো, বুঝছো এটা?
Yes sir, more or less বুঝেছি।
আচ্ছা, এই প্যারাগ্রাফটা বেসিক কনটেক্সটে বলে, প্রিন্টার সাউন্ড আমার এখন বিরত লাগছে, আমি প্রিন্টার খুলে রাখছি, আমরা প্রিন্টিং পরে করব, ডোন্ট ওয়ারি। হিয়ার ইজ দ্য আইডিয়া। P5 এ কি থাকবে? P5 এ আমাদের বেসিক কোশ্চেন থাকে দুইটা। There are two questions in the paper 5. Each questions are 15 marks of worth. It's a 30 mark exam. You have 1 hour to accomplish this your test. Question number 1 is what you call the planning and planning question. in the planning question, you will be given a certain theorem, or you will be given a certain equation, or you'll be given a certain relationship to shape, and you'll be asked to either prove that equation, or you'll be asked to find out the possible how to develop the relationship between those two variables, or you might also be asked to actually prove a certain proportionality relationship or something like that. So some sort of a mathematical equation or proportionality will be given, and a very simplified diagram, which will give you a small bit of idea for how the apparatus, how the diagram that you are expected to draw should look like. As a very simplified diagram would be given, and they will ask you to do that, and nothing else would be mentioned. Now, there are a couple of things in play. The basic idea of question number 1 is that you are to design this experiment in such a way, you have to write about the design of this experiment in such a way so that any person, let's say without any prior knowledge to physics labs, they walk into a lab, they have all the equipments of the physics lab labeled, they will read your instruction, they'll pick up those equipment by reading those labels, and they'll be able to do that experiment perfectly without harming themselves, without damaging the equipments, and be able to come up with a successful experiment by which they will be able to prove that relationship. Your aim, your mental setup or your goal is to write the description of an experiment to that level of detail. That's all that is. This is the general idea for what question number 1 is about. Basically, directing a lab class. এই পার্টটা বুঝা আছে?
Yes, sir.
P4 এর মতনই তো।
হ্যাঁ, P4 তো ছোট ছোট কোশ্চেন আসতো, একটা মনে করো অ্যাপারেটাস সেটআপের একটা পার্ট ডিটেইলে বলা থাকতো, তারপর তোমাদেরকে ছোট ছোট কোশ্চেন করতে। এখানে হচ্ছে পুরো এক্সপেরিমেন্টটা তোমাকে লিখতে হবে, এবং এখানে কিছু সার্টেন অ্যাসপেক্টের উপর তোমাদের মার্কস দিবে, সেই অ্যাসপেক্টগুলো কি সেগুলো আমি পরে বলছি, বাট জেনারেল আইডিয়া হচ্ছে তোমাকে এই ফরম্যাটে লিখতে হবে। This is the first thing. Second thing that I want you to understand is that in P5 we usually have quite a distinct amount of marks distribution. Marks distribution গুলো কিরকম হয় সেটা আমি একটা মার্কস থেকে একটু পরে আলাপ করতেছি, একটা স্ট্যান্ডার্ড কোশ্চেনে আলাপ করব। First of all, আমাদেরকে যে জিনিসটা ডিটারমাইন করতে মনে করো হচ্ছে, let's say let me put it this in a very simplistic term. Consider the scenario that you are asked to, let's say, measure the value of G with the simple pendulum. Simple pendulum, you guys know simple pendulum? Bob hang with string, that's a simple pendulum. So you are trying to calculate that value. Now, what is it that you are trying to, how would you measure that G value from the equation? That equation might be a part of your P4 syllabus or P2 syllabus, ASCT syllabus. It might not belong to that. You can expect mathematical equations which fall far out for your syllabus boundary. That mathematical equation, the existence of the mathematical equation is something that you don't have to bother about. All that you have to bother about is that how you can collect data from your apparatus setup and have a mathematical way of proving that relationship. That's all that you are after. The validness, the deduction, or the inclusiveness in the syllabus of that equation or of the topic is not at all very considered factor for this question's content. Not at all. That's very important for you to appreciate. এটা একটা দরকারি জিনিস। এরপরে যেটা হবে সেটা হচ্ছে তোমাকে, আচ্ছা এখন মনে করো যদি আমি সিম্পল পেন্ডুলাম দিয়ে, আমি সিম্পল পেন্ডুলাম আঁকতেছি না, বিকজ তোমার সবাই সিম্পল পেন্ডুলাম কেমনে অপারেট করতে হয় জানো, তোমরা এএসএল ল্যাব প্র্যাকটিস করছো কিছু না কিছু হলো সবাই। So in simple pendulum, what do? We change the length of the effective length of the pendulum, which is basically the length of the string plus radius of the bob. We change that to some convenient values, and then we measure the time period of oscillation, and then we come up with an equation. Typically, the equation that relates to a simple pendulum with G is, it goes by G equals to 4 pi square L by T square. Let me write that equation so that I can make sense with you kids. This equation looks like this. G equals to 4 pi square L over T square. This is the typical equation. Now you might not have access to this equation. They might give you this equation in terms of t. This equation actually comes from the simple harmonic oscillation equation, which looks like the t equals to pi root over of L by G. This is the exact equation from where this is coming from. Once you square this and change the sides, you come up with this equation. Now what is important that they might give you the right equation, they might give you the left equation, doesn't matter. One thing that you have to understand that if you are trying to calculate some variable out, in some cases you might actually have that calculated variable existing on the, you should actually subject that variable, leaving everything else on the right side. And on the right side is the number of variables that you have present, or even if some variables are not present in the equation, but they might be actually important for your experiment. You have to be able to choose the involvement of this variable in a very specific way. That specific way being that you have to choose which of the variables are going to be your independent variable. Independent variable means which value of the variables involved that you're going to change at your will. For example, for a simple for this experiment of the Bob experiment to measure the G value, our chosen variable will be the length of the string, or something that we call the effective length of the simple pendulum. So we will be able to fix that up on our will, at our will, and depending upon that choice, the time period of the simple pendulum will become fixed. So we will change L, we will measure T. Now changing L also means that we have to also measure L, because if you don't measure L, I mean, we have to change and measure L, and we will measure T. So ultimately, so how would you measure L? Now L measure করার জন্য আমাদের কিছু step আছে. So we have to measure the length of the string very accurately. How are you going to measure that? So you have to give some description about this, and then the length of the string should be added with the radius of the bob. So how are you gonna, what equipment are you gonna use to measure the radius of the bob? What specific properties should the bob have? I mean, should the bob be, can the bob be a cuboid? Can the bob be a pyramidal object? Or if it's a sphere, what kind of sphere are we talking about? Are we talking about an elliptical sphere, or are we talking about a uniform sphere? So to have the effective length, which is capital L, measured up to the center of gravity of the bob, what methods or what precautions or what type of choices of material and equipment that you're going to do, you have to include those details. Like I said, that everything is labeled in a lab. That person doesn't have any idea about physics. They're going to follow your exact instruction, and they're going to do as you say. They will not have any IQ of their own. They just have functioning hands and legs and eyes and ears, and that's all it. Then they don't have any physics background whatsoever. So you have to write your description to that much detail level. And then again, if you want to measure the value of time period, to measure the time period, I mean, one of the beautiful thing about for the case of simple harmonic oscillation is that a simple harmonic oscillation is a continuous process. What do we mean by this? A continuous process means that if you set up a swing in your simple pendulum, it is going to continue swinging. Which means, let's say you start the swing at a certain position of the bob. After one swing finishes, from that instance, the second swing starts, which means you can count the amount of time for multiple swings without interruption. So you can, in a single stopwatch measurement, you can count 5 oscillation time. You can count 10 oscillation time. You can count 20 oscillation time. You can count 40 oscillation time. You have that privilege because the incident is a continuous ongoing happening. So typically what we recommend, that the number of typical recommended oscillations for a simple pendulum is that goes about 10 for a laboratory experiment, because 10 is the number that we are pretty comfortable with for averaging, and it does not cost that much time. So it is within the optimum level of not so costly in terms of time spent. Also, it's good enough for averaging effect. I mean, bottom line, if you increase the number of repetition, I mean, if you measure time for 20 oscillation or 40 oscillation or maybe 100 oscillation, I mean, the bigger the number of oscillation you can measure the time for using the stopwatch, your random error will become far more less. This is what you have learned in your AS level. That I mean, pretty much the only way to circumvent random error in a measurement process is repeat and average. So the amount of effect that you're gonna that random error is gonna have in the calculation of your capital T, which is the time period, which is the average of the measured time, I mean, the smaller the number of oscillations that you use, the bigger will be that effect. So if we take bigger number of oscillations, the disparity due to random error will become more and more less. That's the idea. So 10 is a pretty convenient number, so we typically can stick to 10. Sometimes 20 is the upper limit, 10 is usually the lower limit. Preferably, we do not want to give 5 or less than 10. So the person has to measure the oscillation of the bob for 10 oscillation. Now here's the deal. This person I'm talking about doesn't even know what oscillation is. He doesn't have any physics knowledge. You have to consider that fact. You can simply write the person takes the time for 10 oscillations and then divide it by 10 to get the time period. How does he get 10 oscillation? So you have to mention that the person sets up a fiducial marker behind the bob and observes the oscillation as the bob goes from one side to another, and as the bob crosses that point from the same side, that is one oscillation. In that manner, the person counts 10 oscillation time. So you have to specify that process. Am I making sense? I mean, things you would naturally take for granted for your knowledge level, you have to understand that that person does not have that knowledge base. He is like I said, zero IQ. For physics, he has zero IQ.
স্যার আমার একটা কোশ্চেন ছিল।
আচ্ছা, হ্যাঁ বলো।
আমি বলছিলাম আমাদের ও লেভেলস এর যে প্র্যাকটিক্যাল, ও লেভেলস না, এএস এর প্র্যাকটিক্যাল পেপারস ধরেন, ওগুলাতে তো স্যার অনেকগুলার প্রসেস ভালো মতো দেওয়া থাকতো। স্যার ওইগুলার সঙ্গে মানে ওই টাইপের এক্সপেরিমেন্ট রিপিট আসতে পারে?
হ্যাঁ,
পেপার 5 এ
এক্সপেরিমেন্টের টপিক বা এক্সপেরিমেন্টের টপিকের কোনো প্র্যাকটিক্যাল লিমিটেশন নাই। I mean, any physics relationship or any random Mongo relationship that is possible to achieve with the typically available laboratory equipment, they can show up. I mean, typical laboratory equipment বলতে আমি কি বোঝাচ্ছি? What do you mean by the typical laboratory equipment? They are not going to give you an experiment where you are going to need a cyclotron or a linear accelerator, because that's not available in a regular lab. They're not going to give you an experiment where you might have to use supercomputers for some super complicated mathematical calculation. They're not going to give you a situation where you might actually have to spend like enormous amount of time to execute that experiment. For example, let's say you want to measure the half-life of an equipment of a ferrity isotope that has a half-life of, let's say, 1,000 years. Now, how do you measure accurately the half-life of 1,000 years? That's just too difficult to work with, right? So they're not going to give you ridiculous experiment, or they're not going to give you experiments which might not look ridiculous, but executing that experiment would require additional equipments in the laboratory that you are not usually going to have your hands on. বুঝাইতে পারছি? Shubha, did I get your question answered?
Yes sir. স্যার আমি ভাবছিলাম কি স্যার, তাহলে ওইখানকার প্রসিডিউরগুলো কি মানে মাথায় রাখলে কি সুবিধা হবে এস এগুলা?
ডেফিনেটলি সুবিধা হবে বলে না, ওইখানকার প্রসিডিউরগুলো মাথায় রাখতেই হবে। অ্যাডিশনাল টু দ্যাট তোমাদেরকে আরো কিছু জিনিসপত্র শিখতে হবে, যেগুলো আমি তোমাদেরকে আস্তে আস্তে আলাপ করব। ওইগুলো মাথায় রাখতেই হবে, ওগুলো মাথায় রাখলে সুবিধা হবে না, ওগুলো মাথায় রাখতেই হবে। You are not allowed to forget them. আমি একদম P5 A2 শুরুতে তো বলছিলাম তোমাদেরকে যে we are starting the A2 syllabus. Kids, you are not allowed to forget any stuff from AS. Everything that you have learned in your AS is inclusive. You might actually not be tested for that, but you cannot decide যে fine AS পরীক্ষা দিয়ে পাস করে ফেলছি, পরীক্ষা দিয়ে পাস করে ফেলছি, AS এর মাসের থেকে শিফট ডিলিট করে দিলাম, A2 get started. Well, no. Oh no. Yes, Abias, you have a question. Bolo.
Sir, what's the limit of terminology we can use? Like you said, a normal person, would they understand the term oscillation and stuff, or half-life?
Exactly, they would not know what that is, but they would be able to use a certain equipment. They will be able to press stopwatch, and they will be able to start a stopwatch. They will be able to count the grid number for a certain time in the oscilloscope. They will be able to do those things. So you have to guide them to very precise description how they're gonna be using this equipment to get usable, measurable data in the experiment.
For example, instead if I say observe the oscillation, should I just say observe the back and forth motion of the pendulum bob, something like that.
This is I mean, oscillation. They would know what oscillation is. Oscillation is vibration. But what is the time period? How much time does time period mean for an oscillation? They would know that. Back and forth motion is oscillation. That's known. That's English word and that's vocabulary. That's not basically physics. I mean, but how much is time period? I mean, time period is relevant to one perfect oscillation. Now, how much motion do you define as one perfect oscillation? That is the physics-based knowledge. Oscillation basically means vibration. That is the vocabulary knowledge. Do you see the differentiation line here?
Yes, sir.
Beautiful.
Sir, also another thing.
Yeah, আচ্ছা বলো হ্যাঁ শেষ করো বলো
Like, what's the limit of instruments we can recommend? Like, I can say that you can observe the oscillation from a back and forth motion using a fiducial mark. But what if I just say, put down a motion sensor and wait for it to do your job for you? Would that work?
Okay, good question. I'll answer to this question after a while. It will come into our discussion in much detailed form, but I'll remember to answer this. Sajid bolo.
আমাদের কি ওয়েভ নিয়ে কোনো কোশ্চেন আসবে?
হ্যাঁ আসতেই পারে।
আরে ভাই
Nothing is off limits.
আর স্যার ওই এএস এ আমরা ল্যাবে যা করছি মানে যা এক্সপেরিমেন্ট করছি সব এক্সপেরিমেন্ট গুলো যদি মানে মনে রাখতে হবে প্লাস অ্যাডিশনাল আরো অনেক কিছু আছে তাই তো?
হ্যাঁ
আর আর স্যার এই ফর্মুলা ইউজেজ তারপর হচ্ছে গিয়ে ম্যাথমেটিক্যাল ডেরিভেশন এগুলো সব কি মানে এ টু সিলেবাসে বাইরে যাবে না মানে এস এ টু মিলেই তো থাকবে তাই তো?
না এটু সিলেবাসে বাইরে যেতে পারে। They can give you a random equation that you have not ever come across in your life. Let's say let me give you a very actual practical example. There is this one of this experiment that actually existed in all these things, that you are given a foam block. You are given a foam block and you're going to drop a certain mass marble from different heights of that block. By some mechanism you'll have to find out when the marble will hit the foam block, exactly what is the how much compression or what is the lowest level does the marble goes down as it collides with the foam block before it comes to rest and bounce off. So you have to be able to measure that. Now there is a equation that involved exponential in that process, that you are asked to prove that exponential equation that you have never come across in your syllabus, but the situation that is described is understandable for you. বুঝতে পারছি কি বলছি?
আচ্ছা আর একটা হচ্ছে গিয়ে আপনার এই ইকুইপমেন্ট ব্যবহার যে করতেছি এই ইকুইপমেন্ট কি মানে অফ লিমিট থাকলে হবে নাকি মানে ফর এক্সাম্পল আমি যদি বলি যে একটা হাই স্পিড মানে স্লো মোশন ক্যামেরা আমি ইউজ করতেছি আর স্লো মোশন ক্যামেরা নরমাল একটা ল্যাবরেটরিতে পাওয়া যায় না বুঝছেন
না হাই স্পিড ক্যামেরাজ আর অ্যালাউড।
ও আচ্ছা
আমি হাই স্পিড ক্যামেরা পার্টটাতে একটু পরে আসতেছিলাম। সো হাই স্পিড ক্যামেরাজ আর অ্যালাউড। কি কি নতুন ইকুইপমেন্ট তোমরা ইউজ করতে পারবা সেগুলো আমি তোমাদেরকে বলে দিই। ফর এক্সাম্পল, ইউ ক্যান ইউজ অ্যানিমোমিটার, ইউ ক্যান ইউজ স্পিডোমিটার, you can use high speed cameras, you can also use light gates, which you might have never come across to use in your AS syllabus lab. There are some other equipments that you will be able to use, you will be allowed to use, which I'm not gonna give you a complete list, but I'm gonna talk about them, stuff that I can remember and can talk about. But here's the deal, Sajid, let me tell you this thing. One of the in my opinion, one of the wrong ways to look at paper 5 is to ask the question that we have to learn all of the stuffs and we have to remember all the stuffs. Oh my God. No, it's nothing like that. It's sort of like having pizza. If you wonder, I mean, I always come up with food examples because they make sense to me. Like, if you are asked that, okay, Sajid, you want to eat, you want to have pizza, what do you want to do? You can answer, I'm gonna go into the shop, drop some money, have some pizza done. Okay, that's not a very terrible answer because that works out. But how did the pizza come into existence? Well, someone had to mix up some water with dough and yeast, and they have to put it into some resting time, blah blah blah. Add cheese and macaroni and salami and stuffs and sauce and everything. So that's also another level of detail. But then again, where did this flour come from? Where did this available yeast come from? How did the tomatoes got grown up? Now, if you think for that level, you have to start there. Well, there are some farmers who have some seed who they got from their forefathers. They derived those strains from a lot of trial and error, and they planted those seeds and they cultivated the flower, and then they husked the whole flower. Then they got the grain out. By breaking those grain, they made flour. That's another level of detail. Do I make sense?
So I
The
get it.
question remains the same. How do you eat pizza? But the answer can be given in a lot of different layer of details. ঠিক আছে? So don't take in too much that you cannot chew. You don't have to take that much. Trust me on this one. I'm going to guide you very precisely how much you are supposed to know. This can be very enjoyable as long as you're willing to use the analytical part of your brain rather than the memorizing part of your brain. If you try to memorize paper 5 questions, especially question number 1, you are never going to get a good experience for the first to start with, and you're going to be depressed with paper 5. You cannot work out with this by just memorizing. You have to have a holistic idea how does a physics lab works.
না আমি জাস্ট চিন্তা একটাই আমার আমি ওয়েবস পারি না এত ভালোভাবে সো
ওয়েভস পার্ট ইম্পর্টেন্ট না, তুমি তো অ্যাকচুয়ালি এক্সপেরিমেন্টটা করবা না, তুমি বলবা এক্সপেরিমেন্টটা কেমনে করে করতে হবে। there is a difference. Knowing what I mean, being able to actually use an apparatus very cautiously and being able to take proper reading depends on a lot of personal factor and environmental factors of the exam hall or the lab. But if you want to give someone instruction that you are supposed to do this, you're supposed to do that, don't go right, go left, and then go straight, and then go down, then duck, and then dive, then that's another thing. So you have to be the tactician to give the recommendations. You don't have to fight the war. But important part is your recommendations should be perfect to the most detailed level. That's what I'm asking you. This is just a generalized way to make sense of the question number 1. I mean, the amount of detail, I mean, how much amount of detail should you go for? That's a different issue. বুঝতে পারছি?
জি স্যার, থ্যাংক ইউ স্যার।
আচ্ছা, আরাফাত একটা কমেন্ট লিখছে, মনে হয় অনেকক্ষণ আগে লিখছে যে নুব এন্ড স্ক্রাব। Kids, do you guys understand what noob and scrub means?
Sir, I'm a gamer, so yeah.
Acha, for those who play games, at least MMOs, you know what noobs and scrubs are. Noob and scrubs refer to novice players who don't have any, I mean, that kind of player who get into, let's say in PUBG and dies within the first 10 seconds and they just go around scream, or they keep on watching the rest of the players game for the next 12 or 15 minutes. They are called noobs and scrubs. Like basically who we call feeder. In this case, noob and scrub means who don't have any know-how of the physics lab. Noob Ahmad, mane? Who is Noob Ahmad? Acha, never mind. We will continue the P5 discussion. কি বলতেছিলাম জানো? এই কি যেন বলতেছিলাম? আচ্ছা, হ্যাঁ। But the thing that I was talking about is that one of the beautiful part for the oscillation is that oscillation inherently by its own motion, it is a continuous motion. I mean, one oscillation finishes, second oscillation starts. So you can take the time measurement of 10 oscillations in a single go. But every experiment is not that beautiful. For example, let me give you a simple example. Let's say for a certain experiment, in another experiment, you are asked to measure the value of G by the time an object takes to fall through a certain height. Or basically speaking, that you are trying to measure the value of G using the formula H equals to UT plus half AT square. Now you're definitely going to reach the object from stationary case, so you're going to have U equals to 0. So basically H equals to half GT square. From this equation, you're trying to calculate the G. Now there is a problem. If you can measure how high you're dropping the object from, you can measure that up using a meter rule or a measuring tape, and then you can drop that object. But that object is going to fall through a distance in a very short amount of time. I mean, how long does an object would take to fall through a height of 1 meter, maximum 1.5 meter? Kids, try to understand. You cannot give an experiment which is not going to be happening in a laboratory environment unless otherwise specified. Every experiment should be designed that you're going to operate this within the limitation of your laboratory. I didn't even see that profanity before you specified it out. Now I had to look out up in the chat window and find it out. Okay, everyone, cool it off. I mean, we are all noob in some ideas. I mean, none of you are expert, not even me. I mean, we have noobness in us in a lot of aspects. Okay, so let's forget about this. Listen up. Disregard that. কি বলতেছিলাম আচ্ছা হ্যাঁ so whenever the object is going to be dropped from a measurable workable height for a laboratory environment, you cannot go around for 2 meter 3 meter height. I mean, how far off from an object a person can drop an object, or how far above it is logically possible for a person to be able to measure the height from the ground. It can be 1 meter. 1 meter is pretty good, or maybe a maximum of 1.5 meter, for which you might have to go for a measuring tape. Measuring tape is available in the laboratory, so it's perfectly good as well. Now, in that case, whenever you will drop that object from a certain height, this object is going to start falling immediately. So you have to have a very precise mechanism to start the time count as you release the object, and you also have to have a really precise mechanism to measure out exactly how much time does pass through when the object is at the lowest point of your expected height. So this is pretty difficult to observe and operate for a human being, because human beings are susceptible to a pretty high amount of reaction time in consideration of that small falling time of a stone or heavy object, or maybe a marble, or maybe a metal sphere. So this experiment, for this experiment, you cannot directly measure the time required for 10 fall one after another, pretty much like the way you could measure 10 oscillation time one after another. Oscillations are happening continuously one after another, but in this case the object is not gonna this is not gonna happen. So for you have to measure the time for fall multiple times to get a reliable value for that height. Let's say if you are trying to take the measurement for, let's say, 80 centimeter height from the ground, you might have to do that 80 centimeter height for at least 3 to 5 times the same thing, and take the average of 3 readings to get a reliable data for 80 centimeter. Then you might once again increase it by, let's say, 20 centimeter, then it becomes 100 centimeter. Then you can do the same thing, at least repeat it for 3 to 5 times. 3 lowest, 5 maximum for the same value, and take all of this reading and do the average. So this is an important part, that variables which are not self-repeated, you have to mention specifically that this thing should be done repeated multiple times, do the average, and that average should be plotted on the graph, and then at the end you can say that this is how we're going to come up to this value. এই পার্টটা কি বুঝা আছে? The idea, I mean, the idea that I'm trying to tell you, that a self-repeating variable and non-repeating variable, এই দুই টাইপের ভ্যারিয়েবলের বেসিক মানে ডিস্টিংশনটা বোঝা যাচ্ছে কিনা for the case of repeat and average.
So can you repeat?
Like the time period is a self-repeating variable. You can measure the time required for 10 oscillations continuously. You start the stopwatch at 0, you count up to 10, stop the stopwatch, you get the total time for 10 oscillation, because each oscillations are one after another without any break. But you cannot do the time required to fall a specific height by, I mean, you cannot measure the time required to fall for 80 centimeter continuously. You have to drop it once for 80 centimeter, measure the time, then you have to repeat the same thing. And once you can set up the whole apparatus setup where the object is at 80 centimeter, repeat the whole thing, and then again. So it's not possible to measure 3h continuously and then divide it by 3. That's not going to work out. বুঝছো কি?
জি স্যার।
এই পার্টটা কি সবাই বুঝছো? একটু রেসপন্ড করো। Right?
জি
Yes.
স্যার। জি স্যার।
Or no?
Yes, sir.
জি স্যার।
That's about, I think. Okay. So that's about the idea of self-repeating variable and non-repeating variables. আরেকটা জিনিস হচ্ছে যে we are allowed to use light gates. We are allowed to use high-speed cameras. We can set a high-speed camera. In a high-speed camera, we can set a meter rule behind the camera so that we can go frame by frame, and from the time bar we can take measurement. I mean, you are allowed to use high-speed camera for experiments because cameras are pretty available these days. I mean, you can have, let's say, 20,000-25,000 camera mobile phones which has pretty high shutter speed built in within them. It's possible. It's not impossible. And then you are going to also have access to CROs in cases where you have to measure some voltage, especially in the case of variable voltage scenarios, if you have to work with some generators or AC generators or something like that, or a pulse generator where you have to work with some microphone and stuffs like that. Sound related experiment, CRO can be always be made involved in an experiment wherever it's possible to use. Using a CRO machine has its own advantage, which I'm going to discuss after a while. And the other thing that Abiyaz asked me a little while ago, Abiyaz, I didn't কি question করছিল আমাকে? যেটা আমি answer
Sir, what's the limit of the instruments? Like, instead of vernier caliper, can you use digital vernier caliper, something like that?
সেটা হচ্ছে one of the things that you will always come across in the mark scheme for paper question number 1 is that they always write one thing after the entire mark scheme. Do not credit vague computer methods, which means, let's say you are supposed to do a measurement, do an experiment, and because you cannot think of any option, or maybe you are out of time, or just because you are too creative to believe in, to be believed, you just wrote that we connect all the apparatus to a computer, and the computer does all the calculation and gives us the graph, and from the graph we measure the gradient, and eventually our experiment is done. Maybe you could write it in that way. This kind of information is this kind of description will not be getting remembered. You cannot simply say that we connect a high-speed camera with the computer, and the computer automatically gives us the time required for the object to fall by a height of 80 centimeter. That's not going to happen. How does did you write a program for the computer to do that? Or are you even supposed to write a program within the duration of your lab experiment so that the computer can do that for you? No. What you should say, let's say you are taking a high-speed camera view, you can say that from the time bar of that video feed, by going frame by frame, we can calculate exactly how much time was required. Because by computer, you can have video editing software, so we can give you a measurement of time up to fourth, fifth decimal places. Because in video editing, every single microsecond, you have the option. For those who have ever worked with any sort of video editing, you know what I'm talking about. Okay, so you have to specify the mechanism by which you are going to get some values. So এটা হচ্ছে সেকেন্ড একটা পার্ট। সো আমি এখানে ফার্স্ট আরেকটা জিনিসটা বলে আসছিলাম, সেটা হচ্ছে যে in your experiments you're going to have variables which you're going to choose to change on your own, and then you're going to have variables which will be automatically changed depending upon that which you're going to measure. And just to make sure the experiment works out properly, there would be some variables in the experiment which you should keep constant so that you don't get messed up values. For example, for the case of pendulum bob scenario, we know from our earlier experience that having different mass of the bob does not change the time period for a pendulum. You can have a large bob, you can have a small bob, but for a specific length of the pendulum, you'll always end up with the same T. So that's one thing. But if you choose bobs of different material, let's say for the first reading, for one reading of the bob, you choose a bob that was made up of copper. Then for the second thing, you'll choose a bob that was made from plastic. Now, would these two objects be comparable? In a vacuum chamber, they would still be all right. But would you actually make a vacuum chamber to make experiment with your bob? The answer is no. So, why it is not gonna be a logical choice to use a metal bob and then for the next thing using a plastic bob? Because you have to understand, plastic is significantly less dense than metal. The amount of capability to overcome air resistance or without being affected by air resistance that a metal bob has, a plastic bob would not have that much capability. Plastic bob would essentially get affected by air resistance after a couple of 4 or 5 oscillations. So,
sir, what about the shape? Like aerodynamics?
Yeah, you can directly specify. We use spherical metal bobs, or we use one spherical metal bob through the entire experiment. If you just mention this much, then you are discarding out that variable. You're putting a limit on that variable, which tells that new person that, well, I choose this bob, I work with this bob, I don't change it. That's good enough. Why that has to be done, you don't have to give that reason. So this question number 1 is about describe, not explain. You don't have to explain the physics to the person that why are you supposed to do that and why can you not do that. You are supposed to give the instruction. You're supposed to do this and that. Period. Like army. Do you guys understand? Do you understand why I'm saying I like army?
Because this is a scientific experiment.
No. The way armies work is that they are given a command and they will obey it irrespective of any repercussion. That's how our army works. That's the basic idea of an army. Like whatever your leaders say, that is what your duty is. Period. There is no judgment. Armies are supposed to be basically robots. Super functional, super obedient.
Makes sense.
So you are trying to make an army person work for you, something like that. A soldier work for you, something like that. You don't have to explain your actions to them, but you have to be very specific to what to do so that they are able to do the experiment properly. They don't damage themselves and they don't also damage the equipment. That's all your duty is about.
Also, sir.
Yes.
There's the use of the instruments. For example, I don't know if the person knows how to use a vernier calipers or screw gauge micrometer, something like that. Do I have to describe how they
No. No, you don't have to. Like I said, I mean, this is exactly what we're going to learn in the process of solving those question papers. This is what we're going to learn over the period, which comes in a much detailed version when we'll be solving those question papers, is that you will get to know that to what level of detail should you write that. Like I said, for the pizza example, dropping money is one thing, then making it one thing, is then producing all the ingredients is the second thing. You are gonna go for most cases either to the dropping money case, or you're gonna go in some cases for the cooking the pizza case. You're never gonna go for the production case. I mean, we're not gonna go to the deep root down value of that one. I mean, you're gonna write that if you want to use that, the person uses a micrometer screw to measure the diameter, divide the diameter by 2, there is a radius. Add the radius with the length of the string to get the L. এইটুকু হচ্ছে L measure করার description, which is good enough. And how the person is supposed to use a micrometer screw gauge, they can Google that up, or they can help out themselves however it works. I mean, that description is not warranted. So that distinction line, that how much you are supposed to write and how much you are not supposed to write, is what we're going to learn over practice. So that is something that I cannot explain in absolute detail with you right now. I don't have that capability. ঠিক আছে? All right. So এটা হচ্ছে একটা part. So the thing that I was discussing, that we are going to have some independent variable which you're going to change. You're going to specify that in the equation or in the apparatus which is your independent variable, and then you have to specify that which variable are we going to measure, or which is going to be our dependent variable. You have to understand both the independent and dependent variables should be measured, and there should be some control variables which should be kept constant throughout the experiment for the acceptability of that experiment. All right. And if that variable which you are trying to keep constant is a measurable or a possible to change kind of variable, you might also have to mention an apparatus that will be able to continuously measure that up, and so that you can observe that apparatus and change your variables around, so to keep that constant same. Let me give you an example. Let me give you a simple example. Let's say in a certain experiment, the current in a circuit is supposed to be constant for that experiment to work. So you're trying to build up a relationship between two different variables. Current is not one of them, but it's an electrical circuit, so current will definitely flow. Am I correct?
Sure.
But if you are willing to keep the current constant, you have to have an observation mechanism by which you know that the current is actually constant exactly at the point of taking the readings. Before you take the reading of the other equipments which you are trying to relate with each other, you have to always look at an ammeter that is current in the circuit to make sure that that ammeter reading is same for all of your readings. And let's say if by changing the independent variable somehow your current becomes changed, then what should you do? That can happen. To circumvent that, you have to have a logical way, a physics way, so that you can control that control variable in applicable cases, not in all cases, applicable cases. What do I mean? How do you control the current in a circuit? By adding a simple variable resistor. Let's say for a certain experiment, I'm just giving you some numbers. You will never have to work with numbers for your question number 1, but just to make sense with it. If you are trying to do an experiment where you have found out, where you have stipulated that the first reading of your emitter is, let's say, 0.6 ampere, and you're aimed to, you're poised to keep that current value 0.6 ampere through all the reading that you're going to take for the upcoming readings. Now, if you have to make sure that this current is same, you can simply connect a variable resistor in a circuit in series, and you can also connect an emitter. Variable resistor is to control the value of current. If by some other factors the current becomes too high, you're going to increase the resistance of the variable resistor till that current drops to 0.6 ampere. Then you're going to take those other readings. If the current goes too low, then you're going to reduce the resistance of the variable resistor so the current rises up to 0.6 ampere. So you're going to control the variable resistor, you're going to observe the emitter, making sure it is perfectly at the same level, and then you take the variance of the other two. This is one of the ways in applicable cases where you have to specify how do we control the control variable, and in cases where there are measurable values, we should have that thing, key thing. We should have a way to measure that variable. But this is not always applicable. Let me give you another example. Let's say you are trying to do a thermal experiment in a lab. You're trying to do a thermal experiment in a lab. It is always proposed that your lab should not have any draft. Do you guys know what a draft is?
A breeze of wind.
It's a small gust of wind. I mean, if I give you a small bit of an idea in terms of speed, what a draft is, air is stationary air. Average velocity of the air particles is 0. Then there is draft, then there is breeze, then there is wind, and then there is storm, and then cyclone, and I don't know what comes after.
There was gale in the middle.
Asha, somewhere in the middle there will be gale. I think gale should be pretty close to breeze.
Yeah.
Okay, in terms of speed, that's the speed variance. So draft is a pretty small, typically discontinuous airflow. I mean, a gust of winds is sometimes called draft, but they are pretty mild. So if you're trying to do a thermal experiment, you should not have that kind of random variable affecting your experiment, because that would give you some pretty different rate of heat loss, or that might mess up with your all reading. So this is a type of a control variable that you cannot measure. But you can try to take necessary precautions so that this does not affect your experiment. How you can shut up the windows of your experiment lab, or you can set up here. If you cannot do that for any other reason, you can set up a transparent plexiglass. You can set up your thermal experiment in a plexiglass box that you will be seeing it from the outside, but it will not have any effect of the gust. That's also okay. বুঝতে পারতেছি? If it is supposed to be measured, if it is measurable, then there should be a measuring and controlling equipment involved. If it is not supposed to be measurable, then there should be some specific way so that we can overcome or avoid the change factor caused by that thing. That's all I'm asking. Okay. So I just talked about 3 variables: independent variable, dependent variable, and then control variables. These variables these are the important stuffs. Then comes, how are you going to do that experiment? So you have to start from the very beginning, and you have to essentially draw a pretty detailed diagram. In diagram, couple of things are really important. Hear me out very carefully. If you ask me, sir, diagram ki aakte hi hobe? The answer is a solid yes. Sir, diagram aakle ki marks kom dibe? The answer is a solid yes. Sir, diagram na aakle ki 0 dibe? The answer is no. But you should try and draw a diagram. Always prefer to use ruler and sharp pencils in your diagram. Any diagram that is not labeled is as good as a non-drawn diagram, blank diagram. You draw a very beautiful diagram, don't label anything, you might as well consider not to draw the diagram. So if you're drawing a diagram, label everything in that figure. Always use ruler for straight lines. Don't believe in your hand motion to be able to draw perfect straight lines. Examiners hate that. You cannot make your apparatus arranged as if they are floating in space. You have to give proper support system in your figure, stands and clamps like that. If you are hitting something on above a flame, you might as well at least give a stand clamp that is holding your beaker or holding your the neck of your conical flask, or you might actually draw a tripod under your beaker, or under your tripod, or under your conical flask, so that you know for a fact that sorry, you know for a fact that those things are not hanging in the air. No equipment should be drawn that is hanging in the air. এই পার্টটুকু বুঝা গেছে? ইনফরমেশন এই পার্টটুকু বুঝা গেছে কিনা?
Yes, sir.
ফ্লোটিং ইকুইপমেন্ট আঁকা যাবে না। আচ্ছা, দেন আরেকটা জিনিস বলি, unless essentially required, always prefer to draw two-dimensional figure. In appropriate cases, you can make a mixture of 2D and 3D cases. For example, if you can remember, for the case figure of ripple tank that I did taught you kids in the O levels, I used to draw only the tray as a three-dimensional thing, and the bottom paper, the rectangular paper, where we would have to draw the shade representing the waves as a three-dimensional thing. But everything else I used to draw as two-dimensional. The light bulb, the wire, the stand, clamp, everything was two-dimensional. That's a mixed up figure. That is also okay. Prefer not to draw a three-dimensional figure, because drawing a three-dimensional figure properly, that would make sense to your examiner as well, might be a pretty big risk. But if you're really confident, well, you can. It's not prohibited, but I personally don't recommend it for the mass people. In some cases, it might be required that you might have to draw two different views of an equipment setup. What do I mean by this? Let's say you are gonna show the side view for how the apparatus was arranged. Then how the reading should be taken, you might also prefer to draw the top view of the apparatus setup for some experiments. I'm not giving you an exact example, but in some cases it might be required to draw two different views. Now if you guys wonder, say এটা কি দরকার হবে, well, here's the deal. Stuffs that you properly represent in a figure, you don't have to write a description for them. A properly drawn figure would require zero description for the apparatus setup. You can draw the entire figure properly and simply start writing like this. We set up the apparatus as shown in the figure. That's done, and that's enough. That will score you full marks for the apparatus setup part of the question, if your drawing is good enough. And then you can directly jump in, describing how these apparatus are going to be used to collect reading out of them. Stuff. So here's the thing, try to understand this thing. Your diagram and the description of the diagram should complement each other. Don't write the same stuff that you have drawn in your diagram once again in your description. That's just redundant. Stuffs that you cannot draw in your diagram, you cannot think of a way to draw in a diagram, you write about them with appropriate words so that it is understandable for the examiner / noob person. Stuffs that you can show you on your diagram, you don't have to write about them. If you draw a really poor diagram but give a really good explanation, that might actually work. Do I make sense? Because the reason I'm telling you this, because different people among us have different capabilities in different aspects of your brain thinking and your output level. Some people are good especially with diagrams. Some people are good especially with words. So whatever your strong forte is, you use that for your benefit. That's it.
So is it like আমরা ব্যালেন্স করব বেসিক্যালি দুইটার মধ্যে?
You don't essentially have to balance. You use together two things to get yourself the gratification that, well, this description that I've written is the best description that this noob person could possibly have. That's what you have to be able to tell yourself, that this figure and this description is good enough for anyone to be able to do the experiment. If you can say this to your own self, move on.
স্যার আমি রিডিং এর ব্যাপারটা বুঝলাম না, ওইটা একটু
রিডিং এর পার্টটা হচ্ছে যে apparatus setup তো in the apparatus setup part, in the drawing of the description of the apparatus setup, we're going to talk about how the apparatus is going to set up. Then we have to say that how this apparatus will be used to take individual reading. Now you don't have to, when you have to describe in detail how one reading should be taken, when one complete reading should be taken. Once you describe that up, you can simply say the person repeat this process for multiple values of the independent variable that you have chosen earlier that you have to write about at the beginning of your answer. The person repeats the same procedure for multiple other values of this variable and fills up the table and eventually goes on for the drawing the graph. But how you are going to use that apparatus? For example, if I give an example for the case of the G measurement, gravitational acceleration measurement for the using a simple pendulum experiment, you might as well say that the person sets up the length of the string to a measured length by using the meter rule, where the meter rule 0 mark was placed on top of the bob, and the mark of the and the mark that was aligned with the pivot point or the hanging point or at the hook. Hook is the thing at the hook or at the bottom level of the rubber band. If you include a rubber band, that's also pretty good, because no rubber band, that split cork.
Split cork, yes.
Yeah, that's split cork. So, I mean, I love you. খাতা লিখছো? আচ্ছা, এখানে কেউ নাই? না না, আমাকে একটু চা দিতে বলো, তাহলে হবে। চা বা কফি, যেটা সহজ হয়। ওই প্লেটের সাথে রাখো, ওখানে প্লেট আছে, মগ আছে, আরেকটা আছে, ওই চারটা জিনিস। সরি, কি বলছিলাম? Hello?
The last thing you said was rubber bands.
Oh, rubber band, yeah. Let's say, so you have to specify that exactly what he should measure with his meter rule, that he should set up his meter rule so that the 0 mark of the meter rule is on the top of the top surface of the spherical bob. এই যে আমি spherical bob বলে দিলাম, so এই sphere wordটা আমার অন্য কোথাও না লিখলেও হবে. So if you incorporate small words as adjectives or adverbs in part of your description, you might be actually able to write less words. Do you understand this vocabulary magic here? Okay, never mind. So you place the 0 mark of the meter rule on the top surface of the spherical bob and take the reading at the lower level of the rubber band, which is the length of the string. Then he also measures the diameter of the bob in multiple orientations. Find out the average. Divide that average by 2 to get the radius of the bob, and the length of the string plus radius equals to capital L. ঠিক আছে, এইটুকু হচ্ছে তোমার L measure করার procedure লিখে ফেললা. Then you're going to come across to describe how the person is going to measure the T. For example, if I was writing this thing, I'm going to write this thing. The person sets up a floating marker or a sticker paper behind the bob, which is not going to hamper the motion of the string or the bob, but will be can be used as a reference as the bob oscillates left and right. The oscillation is set up. It should be linear. It should not be the oscillation should not be elliptical, and the person counts number of oscillations as the bob goes past that reference marker from the same direction. এই কথাটুকু কিন্তু একটা oscillation mean করে. The person counts the number of oscillations as the bob goes past the reference marker from the same direction. He starts the stopwatch at he starts the stopwatch. He uses the stopwatch to measure the total time required for 10 full oscillations. কখন stopwatch turn on করবে, turn off করবে, সেটা দেওয়ার দরকার নেই. But like I said, that he is gonna count the oscillations as the bob goes past the reference point. So you're defining what he's gonna do. Then you're gonna say he uses the stopwatch to measure a total of 10 oscillation time. Then you're write capital T equals to division line, উপরে লিখবা time for 10 oscillation divided by 10. So এই তোমার accept data নাও হইলো. Then you're going to write the person repeats that the aforementioned process for different values of capital L, or you can for different values of the string length, and calculates all of the relevant L and T and makes up a table. Later he also calculates the value of T square in his table and include those values. And then we plot a graph of L versus T square on the graph paper. This line, now have a look. If this is the equation, everyone have a look at the video. If this is the equation that we are trying to prove, you can see it very well that this is y equals to mx, right? Like if I plot a graph of L versus T square, I mean, L versus T square should give you what? L equals to হবে হচ্ছে L equals to কি হবে?
GT square by
না
4 pi square.
G by 4 pi square T square and আছে ঠিক আছে না? হ্যাঁ ঠিক আছে. So this is an equation. So what I'm going to write that the person plots a graph of L versus T square. This graph should be a straight line going or straight line going through origin. Now because I can see that this is the equation y equals to mx. I can see it. So the proof that this equation is true is that once we plot the graph and draw the base fit line, that line should be a straight line that passes through the origin. The gradient of the graph is measured, and then you have to write gradient equals to G divided by 4 pi r square. Therefore, G equals to gradient into 4 pi r square. You have to write those in word equations. But if you're trying to measure out the G, ultimately at the end point of your description, you should have G on the left side, and over here some measured calculated numbers who should make up the value of G. G should be subject without anything else. Coefficient 1, power 1, no log, ln, sin, tan, cos kichu thakbe na. G should be alone. And everything else should be on the right side, which should this variable should be able to we should be able to measure from the experiment. We should be able to either calculate it from the experiment. Likewise, এই পার্টটুকু বুঝা গেছে কি?
Yes, sir.
ঠিক আছে, দেখো কারো কোনো কোশ্চেন থাকলে বলো।
আচ্ছা স্যার,
হ্যাঁ বলো।
এরকম প্র্যাকটিস কবে করাবেন P5?
প্র্যাকটিস করানো শুরু করা যায়, অ্যাকচুয়ালি পেপার 1 প্র্যাকটিস করানো শুরু করা যায়, বাট জিনিসটা হচ্ছে তোমাদের হাতে আমার যদি P5 এর বুকলেট তো দেয় তাহলে আমার অ্যাটলিস্ট আর সপ্তাহ ধরে নাও ঈদের কোরবানির আগে হচ্ছে না,
ঈদের পর তাহলে।
হ্যাঁ কিসের কথা হইতেছে এক সেকেন্ড?
P5
প্র্যাকটিস করবে কখন?
Okay sir, thank you.
I can have discussions with you, which is going to be beneficial for you as well. We can do mental exercises, but for that, I'm not going to ask you kids to start writing them down. But you can practice if your school makes you do, which is perfectly good. All right, every practice is valuable. I'm going to try to make sure that you have in your hands the version of P5 and mark schemes that I prefer to give the kids. That you don't have to buy them from anywhere else. I'll make sure that you have them, which comes as a part of your P5 fees that you pay, which is so it's inclusive within your fee structure. So you're gonna have this anyway. এই হচ্ছে আরেকটা part. So once you write up the proper description for one full set of reading, then you can write that we repeat this whole thing for like this, and then we draw a graph and blah 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 blah. And এরপর এখন যে জিনিসটা ইম্পর্টেন্ট সেটা হচ্ছে we have to talk about the safety of the experiment. We have to talk about for the safety of the experiment. Safety মানে কি? Safety দুটো অ্যাসপেক্ট আছে। The first important thing is we have to ensure human safety first. We have to ensure human safety first. After we can ensure if there is no possibility for human danger in a certain experiment, let's say, for example, let's say you're gonna do some experiment using a ripple tank. I mean, other than breaking down the whole glass panel of the ripple tank, there is no possibility a human could be injured. Acha, ripple tank baad. Our simple example ki ase? Bubble experiment. Can someone think of a health hazard for an alive human being from this pendulum experiment?
Getting hit on the forehead from the pendulum.
I mean, is the person supposed to make that big oscillation?
স্যার করতেও পারে, বলা যায় না।
That's exactly what you're not going to allow them to do. Just exactly what you're going to label in your figure when you are going to draw your figure, that theta is theta and theta less than equals to 5 degrees. That should be included in your figure.
ওই যাতে লিনিয়ার হয়।
Exactly. Approximately যাতে মোশনটাকে লিনিয়ার ধরা যায়। Okay, come to the point. Ideally, as far as I can think about, I mean, there is almost no harm that is possible for a person to have from this experiment. So in this case, human safety is not a big issue. So if human safety is not a big issue from an experiment, then you need to talk about apparatus safety. Apparatus safety means you should mention something in that safety factor that so that the apparatus don't get damaged. Human safety first, and then apparatus safety second. Again, now in this case, what can be the apparatus safety? I cannot think of any apparatus safety. I mean, one of the human safety that I can think for this case is that we don't use too heavy of a bob because it might get torn off from the string and if it hits the leg and everywhere, we might get damaged. That can be one of the. I mean, you are not going to essentially mention how much mass of the bob should be, but the bob should not be too big, like let's say like a bowling ball. That can be also used as a bob. Think about it. It's a spherical object. Why not? But we should thank you. For laboratory experiment, we should not do that. We should not prefer to do that. So that can be one of the human precaution. Let me give you some other example, some other experiment, because this is not a good experiment for discussing the safety factor. Let's say in some experiment, you are trying to work with the heating of an electrical circuit. For some experiment, you are trying to work with the heating of an electrical circuit. Now, what is really important, the part of the electrical circuit which is going to produce that heat, you should be careful not to touch that part with bare hands, right? And then again, if you're heating something with the electric heater, in most cases, if you're trying to heat up something with the electric heater, we use some sort of liquid to have good heat transfer by convection current. So you can have some oil or you can have some water. In some cases, if allow is possible to use. I mean, typically we prefer to use oil because oil is a poor conductor compared to water. So if you use water for electrically heated experiment, there's a possibility that that water can become conducting medium, and you might have some case of short circuit, which we really don't want to have. So in many cases, oil is a more preferred liquid for heating experiments, electrically heating experiments. But interesting enough, if you use a certain oil, you should always limit your experiment temperature so that the oil never gets to boil. Because if the oil boils, you're going to have splashes, and if they fall on your skin, you're going to have splinters. So you don't want, not splinters,
Blisters.
Eh?
Blisters.
Blisters, yeah, you're going to have blisters and so on, skin burn and stuff. So that's a important human safety. Then again,
oil আসলে কিসের জন্য লাগবে?
For an experiment where you're gonna do some electrical heating by some heater, and you're trying to measure some, let's say, specific capacity of oil. You're trying to measure the specific capacity of oil. That's the experiment.
ওরা কি water use করে না because of মানে hazard, electric hazards or অন্য কিছু?
Water is preferred not to be used in most cases of electrical experiment because water, I mean, having a 100% distilled water is very difficult. And if you use water can become, if you use tap water, that usually works as a pretty good conductor across your circuit. So the amount of current that flows through that water usually remains unwarranted or uncalculated, which can give some rise to problem. But water can also be used if you provide the information around that. We wrap the electrical heater with an insulator material, and then we use that heater, submerge the heater into the water so that there is no possibility of electrification in the water. But then again, if you wrap the heater with some sort of insulation, you're basically reducing the rate of heat transfer. You're losing efficiency. Your heater might get overheated, and your heater might actually do some damage to its own self because heat is not getting dissipated out as fast as it is supposed to work with. So there's other set of problems that can happen over there. So better you avoid water, use oil, which pretty much circumvents the whole problem in the way to begin with.
Sir, what about delicate instruments like variable DC supply and CRO?
Yeah, you can use that. They are allowed. Variable DC supply is basically nothing. What is a variable DC supply? You have a supply and you attached a variable resistor with it in series. That's a variable DC supply. Right now.
Okay. Because at school I saw these big boxes and stuff with knobs.
Exactly. It comes in big boxes, true, but think about what the big box should contain. A fixed supply with a variable resistor with it. You connect everything around, and if you control the value of the variable resistor, you basically control the output of the voltage. Simply put. So in appropriate cases, human safety is the first thing that you have to talk about safety. So that's the about that's the so short discussion about safety. Safety can have a lot of different aspects depending on the experiment, which we're gonna cover quite a good number of experiments hopefully, because we have 3 days classes per week, so we should be able to do a good number of P5 questions, irrespective. And the next thing that we are really interested is about precaution. Precaution is a pretty important part. Precaution is about in the scenario of taking the readings and doing the apparatus, what specific precaution should you take? Like for example, using a fiducial marker or a reference marker behind the moving bob to be able to observe the oscillation more accurately is as precaution actually. Now, one thing that is very important, whenever you will come across the mark schemes, you'll find out that in the mark schemes, they distinguish all of these mark scoring point. For example, they have 3 marks for the mention of independent variable, dependent variable, and control variable. Then they have 5 marks for the process of data collection, which by inherently involves the diagram as well. I mean, the diagram plus process of data calculation together, they have 5 marks. Then comes the part that once you collect the data, how you're going to prove this relationship is correct, which is basically how you're going to mathematically use those data. I mean, plotting a graph and measuring the gradient and blah, 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 and ultimately doing the calculation part. Giving a proper description of that part gives you some good number. And in some cases, to be honest, in quite a good number of cases, you might actually have to do a pretty good amount of manipulation of the equation to come to this part. For example, let's say if you have an exponential equation. Let me write an exponential equation. Let's say for a specific circuit, they're asking you how to calculate the tau. Now, if you want to calculate the tau should be subject, right?
Sir.
So how do you make the tau subject? And tau ka subject kote obosshoi kote long term nite hobe na?
Log lagbe.
Log lagbe. তার মানে কি তোমাকে equation, you have to be able to convert that mathematical equation in appropriate steps, and so that you can make that unknown variable that you're trying to get at to be as the subject of your equation. So that mathematical manipulation also always sometimes have up to 2 marks, 1 mark or 2 marks. Then comes the safety part. The safety usually have 1 mark. Precaution added with the additional details usually have 5 to 6 marks. Additional detail means that, like I said, that whenever you are taking the data, let's say for the case of taking the time period of measurement, if someone measures that the person measures the time period and then records the value, they do no mention about taking 10 oscillation time period, then they're gonna lose additional detail. Let's say if the student writes about the measuring the length of the string, but forgets about writing about the diameter measurement and converting that into radius for the measurement of L. What I mean is that if someone writes that length of the string equals to capital L, if someone writes that and forgets altogether about the effect of the radius, they might lose 1 additional mark. These 1 additional marks are actually given under a single heading in the mark schemes, but as far as I'm concerned, the way I teach the kids, which I personally find pretty workable, is that you should not try to write your answer in the way that the mark scheme is designed. That is very mechanical, and the reason the mark scheme is designed that way, so that the examiners can have their way easily around the person's copy. When you're going to write the description of the whole planning experiment planning, you should write this dynamically, which means that you're going to write these up in the way you feel they are understandable, and preferably write in paragraphs. The examiner is going to give you the additional additional detail mark in appropriate cases. They're going to give you the analysis mark in appropriate cases. They're going to give the relevant mark in different parts of your answer. And if everything is all right, you can essentially get full marks out of it. No big deal. Don't prefer to write additional detail differently, because this is what makes the whole description part pretty difficult to work with. I mean, think about it. Let's say you know by your heart that taking 10 oscillation is an additional detail. Let's say you know this from your experiments and practice. So you think that, okay, fine, it is additional detail. I mean, last year all the heading additional detail একটা heading দিয়ে আমি এটা লিখবো, পরে গিয়ে দেখা গেল তুমি লিখতে ভুলে গেলা. So don't do that. Whenever you're writing, write everything that a person is supposed to do on that time instance when he is doing the experiment, and so that all of your additional details should be embedded in the process of your description, either in the process of the apparatus setup or data collection or the analysis process or the safety and blah blah blah. That's how I personally prefer the kids to write, and that's what the CA people, they don't actually recommend something. I mean, the writing style can vary from person to person. I mean, for example, you might come across some teachers who are gonna tell you that you should follow the exact structure of the mark scheme to write the answer of question number 1. This is actually convenient for the teachers to take the copy. I definitely agree with this one, but this is not very dynamic, or this is not very alive. I mean, if you write your answer in that manner, this person that you are writing the descriptions for would have to actually go through the entire description once. They have to remember that they're supposed to do that when they're supposed to do something else. So they have to continuously go back and forth between the process of working and the additional detail to relate to those 2 points, so that they will be able to do those things over here. Because other than that, if they go continuously read and work, they're gonna do the experiment badly, and at the end of the experiment they'll see, hi, এখানে তো এটা করার কথা ছিল, ওইখানে তো এটা করি নাই, hi, তাহলে আমি পুরো experiment আবার প্রথম থেকে করা শুরু করব. That's simply, in my head, in my understanding, is not essentially the best way to do an experiment or to describe an experiment. Doesn't work that way. বুঝতে পারছি?
So we write it in a way so that it's easy for them to do as well, right, sir?
So that it's easy for them to do this, and so it's easy for them to execute, simply put.
Sir, you mean যে আমরা randomly মানে we can just follow our own order, আমাদের কোনো structure দিতে মানে structure follow করতে হবে না, right?
না, you don't have to, but you should
মানে
write
heading তো দেওয়া লাগবে না
না,
মানে okay.
and don't preferably write headings, যে variables, then data collection, then analysis, then safety. Don't write headings, write in paragraphs, simple paragraphs. বুঝা যাচ্ছে?
জি স্যার।
আচ্ছা, যদি মোটামুটি বুঝা যায়, what I should do or what I can do. This is a 6-page writing. Okay, other than me babysitting you, I'm gonna send this PDF right now into your messenger chat. I want all of you to download this immediately and read this entire 6 pages in 6 minutes. What should be the name of this thing? A2 P5 question 1 notes. That works?
Yes, sir.
Yes, I hope it does. Okay, sending this out. এখনই নামায় সবাই এটা পড়ো, পুরোটা পড়বা, পড়ার পর যা যা না বুঝবা সেগুলো আমি একবার আলাপ করব। আমি এতক্ষণ যে কথাগুলো বলছি এই কথাগুলো এখানে গুছায় লেখা আছে।
Okay, sir.
So I'm gonna pause recording because I would like to give you some dedicated time. We'll resume class after 12 minutes. 6 page, 12 minutes. I was kidding when I said 6 minutes. That's just bullshit. So pausing the Okay, I'm back. Enough time. পড়া শেষ হওয়ার কথা। বলো কি কি বুঝো নাই?
Sir, এখানে একটা পয়েন্টে লেখা ছিল যে we have to like measure or write down all the angles in radians. Why is that?
Wait.
Wait, let me just find it out first. It was written.
Sir, in page 4, at the end of page 4.
Oh, if an angle is directly used, it must be measured or converted into radians. সেটা হচ্ছে কি রকম? Let's say if an angle is not used with a trigonometric ratio like sin theta, cos theta, tan theta, এগুলো দিয়ে যদি use না হয়, directly theta use হয়. For example, let's say s equals to r theta. S equals to r theta equation. If you want to use the s equals to r theta equation for a certain mathematical calculation, that theta in the equation has to be used in radian format. You cannot use degree.
Acha.
That's what I meant. Directly means without any trigonometric ratio. That's what I meant.
Acha. Okay, thank you.
Sure. Anything else? Anyone?
So, sir, যদি আমরা
Yeah.
manipulate করে, like let's say we get ln v as our y-intercept and we need to find that, তখন তো আমাদের বলে দিতে হবে, right, যে আমরা কি করে ওখান থেকে v-টা বের করবো mathematically.
Exactly. বলতে হবে।
আর স্যার অলসো যে ড্রয়িং এর কোয়ালিটিটা নিয়ে একটু কনফিউশন ছিল, ধরেন ড্রয়িং যদি মানে তেমন সুন্দর না হয় বা ভালো না হয় তাহলে কি মার্ক কাটার সুযোগ?
ওইটাই সে বললাম যে over the period of your practice or worksheet solution, you are gonna have a understanding that মানে in which part you are capable to put most information at. মানে method of data collection is gonna be really important. For example, let's say if you are not willing to draw a set square to make a vertical meter rule to be vertical, if you don't want to draw that, or if you are the type of person that who does not draw that, you should write about that. We use a set square with the meter rule and the table to make sure that the set ruler is vertical. So either you draw the set square in the figure or you write that up. That's your choice. But they should complement each other to give the whole information. Figure সুন্দর হওয়া বাধ্যতামূলক না. Figure is not expected to be beautiful. It is supposed to be informative.
Sir, I have a question about the physical.
Rafi, তোমার question answer পাইছো?
Yes, right, I get it. They should just complement each other.
Exactly. হ্যাঁ বলো, আবিদ বলো।
Physical variables, sir. Like, do we have to have an electrical instrument to measure that exact quantity, or do we just can we relate it to another quantity and go from there?
Like what?
For example, light intensity in an LDR experiment, for example. Do we have to get some device to measure light intensity directly, or can we just measure how much voltage is being supplied to the lamp?
You can convert it into other variable if that is logically possible. For example, if your experiment is relevant for an LDR, an LDR might be involved. Or in some cases, if your experiment is dependent on a photocell, let's say you're gonna change the light intensity on a photocell, and from that photocell you're going to measure the voltage and be able to plot that data. That is also possible. In some other cases, it is also possible. We have not yet come across the chapter of photoelectric emission or photo emission. Some cases you might, photocells basically work with photoelectric emissions. So that is also, it can work in either way, but there has to be an equipment involved which must be able to give you measurable data. That's important.
In some way or another, we will have like quantitative measurable data.
Exactly. It should be able to give you some quantifiable measurement.
So about the wind speed thing, if we let's say we're controlling wind speed using a fan, the rate of rotation will suffice, right?
Not entirely. I'll tell you why. Whenever a fan rotates and making you a wind, it usually produces turbulent flow. Now, you don't have laminar flow, turbulent flow in your syllabus, but you can look it up in Google what they mean. Laminar flow basically means all the air molecules generally flow in a single line. They don't cross in each other's way. They flow parallel to each other. That's what we mean by laminar flow. Turbulent flow is the case where the flows crisscross each other. Each individual molecule go around each other. So if you want to do a wind experiment, it is almost in all cases it is very important that the point where this wind speed is to be measured, the speed of the wind is supposed to be laminar. You cannot essentially measure the speed of a turbulent flow with an anemometer. It doesn't work that way. that gives you different variables or wrong readings. So so only controlling the measuring the RPM of the fan from which the wind is produced is not going to be good enough. You would require an anemometer at the end of a wind tunnel. Wind tunnel is the honeycomb shape long structure which makes the whole wind laminar. But you have to use an anemometer. Anemometer is the name of the device which measures wind speed. This is basically a handheld device which has 3 cups on the top, and whenever wind flows by, it rotates at a certain speed. They are calibrated in a way that rotational speed can give you directly the wind speed. Do you know what I'm saying?
Yes, I understand.
So for those who don't know this, let me just show you a picture because I can. Why not? This is what an anemometer is about. So these are stand devices which measures the speed permanently, or if you can also have a handheld device. You can hold it in front of a wind tunnel, measure the wind speed directly out of it.
Sir,
Yes.
sir, এগুলো তো
এক minute, sorry, hold on, এক minute. So Abiyaz question. So measuring only the RPM is not going to be a dependable way to control the wind speed or measure the wind speed. But if we have a certain scenario where we have to change the wind speed for different reading being taken, then it would be warranted that along with that fan which is going to be responsible to produce the wind flow should have a variable resistor connected with it, so that the controlling by the variable resistor, you can control the speed of that fan to produce a high speed wind or a low speed wind. That would be required. But what would be the wind speed at the end of the tunnel or for the actual experiment happening is not going to be a very dependable reading only by measuring the RPM of the fan blades. That's not going to work out.
See, sir. Thank you.
Sure. হ্যাঁ সাজিদ বলো।
স্যার এগুলো তো এইসব অ্যানোমিটার ইউজ করা হয় তো ওই খুব অল্প স্পিডের জন্য, মানে ব্রিজ ক্যালকুলেট করার জন্য কত স্পিডে যাচ্ছে। তো এইসব ক্লাসিফিকেশনে কি বলতে হবে যে এটা বেশি উইন্ড স্পিডের জন্য হবে না?
No. Anemometers can be found for a lot of range. Anemometer is the basic primary device that is used to measure all sorts of wind speed. Even in cyclones, the device which measures the wind speed for cyclone is also an anemometer. But what happens is that depending upon the possible range of wind speed, they can be robustly made, they can be lightly made, they can have different choice of materials. So, I mean, for a laboratory equipment, these cups can be made from plastic. But if you plan to use it in the Hawaii where hurricanes are pretty prone, you might as well consider to make those entire structure with steel. But it is possible to use those devices for a lot of range. That is not relevant. That's the bottom line. The answer to your question is that the adaptability of that equipment is not very relevant, but there always lies a question that in cases you would be expected in some cases, not in all cases, to use your basic idea of equipments to choose a proper instrument. For example, let's say if you are doing an experiment where you are supposed to measure the temperature inside a vacuum tube. Let's say there is an experiment where you have to design a setup where you are supposed to measure the temperature inside a vacuum tube. You are not supposed to be, you should use, I mean, in those cases, using a normal mercury glass thermometer might not be a good idea. A thermocouple thermometer would be a much better idea.
আচ্ছা, I get it. What are you trying to say?
So, ওই জিনিসটা।
Thank you.
Any other question, anyone?
Or one last thing.
Yes.
Additional details. You said to sandwich them into the main writing.
I appreciate that way.
If we don't remember, can we just add it anyway at the end?
Yes, you can. That's another benefit of writing in paragraph format. Let's say you have finished. I mean, Asha, at this point, I would like to add one more thing. The way I always recommend to go for the paper 5 is this. Once you have the paper 5 question in your hand and the examiners and the invigilators give you a get-go to turn over the pages, turn over question number 1, read question number 1 at least twice, preferably 3 times. Get some idea that what the question number 1 is about. Take about 5 to 10 minutes for that. Then jump into question number 2 and take about 20 to 25 minutes, at max 25 minutes, to finish up question number 2, which is very much possible, and I'll teach you how to do that. Then you're going to have a healthy 30 minutes time to draw right question number 1. beauty of this process is that by the time you'll be solving your question number 2 with the active part of your brain, the dormant part of your brain being minimized, your brain will already make up quite a good number of information that how question number 1 can be executed, which works really well. Read question number 1 first, take some time, go for question number 2. Question number 2 is a very, very mechanical paper, like 2 plus 2 equals to 4, that way. I mean, you just have to do a lot of calculation and quite a good amount of graph drawing, and you're done. Initially, it's going to cost you a lot of time because you'll be stumbling into steps, but it is possible to make this very, very fast. I mean, question number 2 is something like memorizing the tables. When you are at class 2 or 3, memorizing the tables was not a good experience for most of us, I believe. Was it?
Hell no, sir.
But once you did memorize it, you became pretty good about it, right? That's the whole point of
Yes,
memorizing the
sir.
tables. Yeah. So question number 2 is something like that. Initially, you will be stumbling a lot, like a lot. But once you get to understand what is happening, you will become very, very efficient at it. I'll make you. Abhias, did I get your question answered?
Yes, sir.
Okay. Kids, it's about time. I have already held you for 6 minutes over the typical stipulated time. So we're gonna close out the class for today, and I'm gonna start. We will talk about question number 2 in another class once again. So now, next class, I'm gonna solving the remaining problems of thermal worksheet. We didn't finish it altogether. I jump started the static electricity capacitor because I was planning to go to Chittagong, so you had a bit of a gap. So next class, I'm gonna start the thermal paper, which I hope that you have completed, or at least to your best capability, you have done most of the problems, or at least half of the problems that you have attended, which I take as the minimum requirement. And after we are done with the thermal paper, we're gonna finish the capacitor chapter. Once we're done with the capacitor chapter, we'll stop admission in your A2 batch, and then we'll start the discussion for electromagnetism chapter. Thank you very much.
Yes, sir.
স্যার আমি একটু কোশ্চেন করতে যাচ্ছি।
Hello.